Let's take a moment to explore one of the sub-assemblies of the example robot. I'd like to take you through the steps of creating this assembly so you may experience success with your design. Using the Free Orbit button, holding down the Shift key and dragging your mouse will give you a nice orbit or view of the feeder wheel assembly. Let's take a look at the parts involved in this assembly. To apply an assembly constraint to the flat bearing and the drive shaft, I'm going to select the center axis of the flat bearing and one of the sides of the drive shaft. Next, we'll select the side of the drive shaft and the center axis of the flat bearing again. Notice each time I'm adjusting the offset of the mate to 0.0625 in either a negative or a positive direction. This allows the flat bearing to be centered exactly on the drive shaft. Going with a flush now, and the flush offset is going to be 0.5 in this case. The next assembly constraint that we'll use is the angle constraint, and this will ensure that the flat bearing does not rotate about the drive shaft. When you use the angle constraint, be sure to select a flat surface rather than a tapered surface, as this constraint will most likely not work if it is a tapered surface. Remember that each component in an assembly has 6 degrees of freedom. It can move translationally and rotationally around X, Y, and Z. So the name of this game is to take away the degrees of freedom. When a component is fully constrained in an assembly, it cannot move in any direction. When you place a constraint between two parts, you remove one or more of the degrees of freedom. An example would be mating the back side of this gear to the front side of the flat bearing. Early on, as you're building skills in Inventor, it can be frustrating deciding what part should get what constraint. But as you build your skill, you'll begin to understand how assembly constraints behave. If you aren't quite sure if you have a part completely constrained, you can go to the View tab and select the Degrees of Freedom button to check whether or not a part has been fully constrained. If you would like more information about assembly constraints, you can visit the Digital Study Packet on the Autodesk Digital STEAM website. Now that we have all but one of the parts placed on the drive shaft, we'll finish up with an angle constraint on the shaft collar. Once you've completed your assembly, it's very easy to make changes. For instance, I may decide I need more space between the spacer and the flat bearing. Editing this mate constraint is super easy by going over into the browser, locating the part that you would like to change, and then further locating the constraint that needs to be edited. In this case, I'll adjust the distance, and you'll see that the assembly is immediately updated. And now it's your turn. Give it a try. I bet you'll do great.